regarding the demand response in smart grid. Okay, so why I have chosen this topic is normally in power sector, what they do is they try to generate the electricity, and through transmission lines it is being transmitted, and the consumers will receive the through distribution lines the consumers receive the power, and we used to use the power alone, and according to the usage of power we try to pay the amount for the utility, isn't it? This is what we were doing till now, but now we are being given a chance to they have provided us, all the consumers are being provided a chance such that we can be a part of that power distribution environment, and we can take a part in reducing the peak load on the system by changing the normal energy consumption, and help the power sector in performing their business in an efficient and reliable means. Okay, that is we can normally what happens is the power sector, they used to generate electricity, and they have to meet the demand with efficiency and reliability. Okay, so the demand and supply must be balanced always. The demand must be equal to the supply. Why such cases? If the demand is not equal, what will happen? Then it will be difficult to we are trying to balance the supply and demand in order to maintain minimum demand level and to minimize the waste and to prevent the base load plant shutdown. Okay, that is one part, and the another part is to keep the low maximum demand, because depending upon the maximum demand we need the power plants, the generating plants, and if the maximum demand goes on growing, what will happen is we have to build more new power plant, which will cost more. Okay, so we have to avoid that building new power plants, and we have to reduce the as more power plants are being built, they will cause the emission of greenhouse and other pollutants, which will spoil the environment also. So we have to reduce that also. The emission of greenhouse gases and other pollutants has to be reduced. Okay, then we have to lower the usage of peaking power plants. That is, we have certain power plants as base load plants, and certain power plants will act as peak load plants. This base load plant will be efficient, and the cost of generation from the base plant will be less. But in the case of peak power plants, the cost of generation will be more, and it will operate only for a very less time during the peak hours. The load demand is not equal at all the times. Since the load is varying depending upon the load, they have to generate the power. Okay, so because we are unable to store electric energy, storage is very costly. Of course, through batteries we can store, but it will be only a very little amount, and the storage of electrical energy is very costly. The utility must generate the power in such a way that every minute the demand is satisfied, and it has to match the demand. Utilities will try to match the demand. How they do is that it is by throttling the production rate of their power plant. Okay, through AVRs and other things, they try to match the demand. Okay, so the electricity production and consumption must balance at all time, and this is a power distribution is also a business. It is a business. Okay, so it must balance, and any imbalance will cause the grid instability, and it will also cause severe voltage fluctuations and cause the failure of grid. Blackouts, brownouts will be caused because of uneven balance between if it is not being properly balanced, it will lead to brownouts, blackouts, etc. Total generation capacity will be sized to the total peak demand, with some margin for error and contingencies. Okay, so the less expensive generating plants will be first used, then the next one. Like that, we will go on increasing the number of generating plants depending upon the cost of the unit produced by the plant. The more expensive or less efficient plant will be avoided because the cost will be more. Okay, if generation is from a higher cost source, the consumers will have to pay very high amount for it. So these are the reasons why we have to always try to balance the power generation and the demand. Okay, always it must be in a balanced condition. I hope you people will be getting this. And the power producers, they have to give the power in an efficient and reliable way. What do you mean by efficiency? Efficiency is the the cost of power should be less, both the operational cost as well as the generation cost. Anything? There is some noise. Please, participants, try to mute yourself. Participants, kindly mute yourself.
Madam, you can mute all, madam. Like yesterday's session.
Wait, I have to go to.
You better to mute all.
Wait, sir. How to mute all? Since I have put the PowerPoint in a slideshow, it is difficult for me. Okay, but now the sound is less, so I will try to continue.
Madam.
So it must be in an efficient and reliable way. Efficiency is the cost of power generation, operational cost should be less, as well as the losses must be less, and there must be a good service for the customers. Best customer services must be there. So these are the ways for efficiency. And reliability is the power quality and the availability of power should be good. Always, all the 24 hours we must be capable of using the power at whatever time we need. Okay, and the power quality should be very good. Okay, but nowadays only we are talking about this power quality. I'll say why we are talking about power quality more now, okay, compared to the previous years. Okay, so the supply must be equal to the demand. The concept is the supply must be equal to the demand, and always it must be matching. Okay, so what we do in this business is power is being generated at a particular place, and it is being transmitted by means of transmission lines, and it is distributed, and the end users try to use this power. Okay, so there are two parts. One is the supply side and another is the end user side. So the supply side is both the generation, transmission, distribution comes under the supply side management, and the consumer side will go for demand side management. Okay, in supply side, in case of generation, the what are the improvements that can be done is the heat rate improvement. Then what we mean by heat rate? Heat rate is the efficiency of the generator, that is the power plant. What is the efficiency of the power plant? Because the fuel is being converted into heat, and then the heat is converted into electricity. So heat rate is the amount of energy that is being used by an electrical generator to generate 1 kilowatt hour of electricity. So to generate 1 kilowatt hour electricity, what is the amount of energy that is being used is called as heat rate. So that heat rate improvement will help us to reduce the cost. The second thing is the plant load factor improvement. What is this plant load factor? What is load factor? That is the average capacity utilization of the unit. It might be a thermal unit. Okay, so average capacity utilization. duration, how long, if there is a power plant of 500 megawatts, for how much time it is being in operation, gives the plant load factor. Okay, if the plant load factor is more, then the cost of energy produced will be less. That is, the cost per unit will be less, and the revenue generated by that will be more. Okay, so that is called as a plant load factor, which can be improved. Okay, then the clean fuel. Clean fuel is, we can generate the coal that is being used can be of good quality, and so that the emissions are less. Okay, and then renewable energies can be used in order to generate the power, so that we can avoid the greenhouse gas emissions. Okay, so these are the things that can be done from the generator side. And then in transmission and distribution side, the transformer ratio and the efficiency of the transformers, and then using correct size transformers, and the conductor sizes, that is, the conductor sizes can be correct, as well as the conductors can be copper, so that it can without losses it can deliver the power. And then reduce the pilferage. What is pilferage? Pilferage is the theft. Normally we used to hear that they used to put a hook and take electricity for meetings and other things and all. So such type of pilferages can be reduced. That is, theft can be reduced. So these things will improve the supply side. Okay, these are the things that we can improve in the supply side. And but there are limitations on what can be achieved on supply side, as some units may take a long time to come up to full power, and then some units may be very, very expensive to operate, and the demand may be at sometimes greater than the capacity of all the available power plants put together. So there are these are the limitations in the supply side. So now what we do is we go in for the demand side management. We go in for the demand side management. Demand side management is the end user side. Now nowadays the end user side are a part of power delivery system. We can if we think we can change the power sector in such a way that we can use the available generating power plants itself in an efficient way by shifting our load to different timings. How to do that? That is what we are going to see. And this is demand side management. In demand side management, what are the factors? It is the systems approach to improve the process. That is, every process, every factory, they can think of their own ways in order to improve their efficiency. Okay, then we can use efficient equipments. Nowadays we people are aware of this efficient equipments. That is, we are now replacing our refrigerators as well as the air conditioners with the 5-star ratings, which shows that it will consume less power. Okay, these are the efficient appliances which will consume less power. Okay, and the main thing is stagger load profile. That is, this is called as demand response. Stagger load profile. What do you mean by stagger load profile? That is, we are the consumers and we are using power, but the power usage, if the average power usage is for all the 24 hours is constant, then it will be good. But it is not like that. The power usage is being either lower at sometimes and higher at sometimes, which we call peaking period. If we, during the peaking period, if we are capable of clipping that peaks, then it would help a lot in reducing the cost. Stagger load profile. That is, changing the load from at time of usage. The time of usage can be changed so that the cost of power generation will come down. and the tariff regulation. Now, at present, what happens is we are at whatever the time we use, we are paying the same amount, isn't it? We are paying the same amount, and at present, the consumers will pay are paying a fixed price per unit of electricity, independent of the cost of production and the time of consumption. Okay, both the cost of production as well as time of consumption does not depending upon this, our cost is not varying. Always we are paying the same fixed cost, and the consumer price is being established by the government. But instead of this, if we are asked to pay different cost depending upon the time of usage, then we will be given privilege. What we will do, we will try to consume the power when the consumption is less, that is the peak load is less, below the average value. At that time we will try to use the power, so that during that time, if we are using the power, we will also be given incentives if we are trying to use the power at the when the load is very less. Because if we are not going to use that power, then what will happen? The peak load, that is the base load plants will be there will be a chance of even shutting down of the base load plants. Okay, that is very difficult. Okay, so during that time, if we use the power, then we can try to maintain the power balance. Okay, power balance, that is the both supply and demand will be balanced. Okay. The utilities will generate power in such a way that every minute the demand is satisfied, and they will try to match the demand by throttling. Okay, by throttling. So these are the ways in which we can focus on the demand side management. So demand side management, this demand side management, it has two parts. One is the demand response, and another is the energy response. One is the demand response, another is the energy response. In the demand response, we have two things. One is the direct load control, and another is the innovative pricing. The pricing, that is direct load control, is the load can be shifted. Load can be shifted from depending upon the timings. Okay, if depending upon the timings, we'll be able to shift our load. Okay, and another is innovative pricing. Okay, these are the two things that come under demand response. And then the energy response. In energy response, conservation, that is saving energy. Normally we go in for saving energy, because we know that 1 unit energy, if it is being saved, it is equivalent to producing 2 units of 2 units. It is equivalent to producing 2 units. That is, generating 2 units will be equivalent to saving of 1 unit. Okay, so and then the energy efficiency. The energy efficiency is nothing. We are using nowadays we are using appliances which are very energy efficient. That is, it will consume less power. Even though the cost at the time of procuring it will be high, the energy consumption will be less. So we will try to do that. So this is demand side management. Demand side management, it is direct load management as well as in the pricing. Both put together will come to demand side management. That is the direct load control, then interruptible tariff, and demand bidding. Okay, demand bidding is depending upon the time we can ask for the amounts. Then indirect load management, it is the pricing programs, and then rebates will be given, and then education programs. This education program is nothing. The consumers will be educated to use energy during the low during the low load. When the load is less, if we use energy, then we will be given some incentives. So the financial status of the power sector can be effectively improved by this demand side management. So this is demand response, conservation, and energy efficiency. This demand response, it is the reduction or the shift in the energy use during the critical periods of short duration, delivered immediately. Okay, so the demand response is only needed occasionally and just for few hours during the critical time. Okay, so that is demand response. And then energy conservation is the saving of energy. That is, when we go out of the room, we can switch on the light, switch off the lights and the fan when we leave the room. Like that, we can say, try to save energy. Okay, and then energy efficient equipments, that is, we can use energy efficient equipments which will save the electricity. Okay, so the demand response is energy conservation, energy conservation, and energy efficiency put together is demand side management. So demand side management, it refers to, it is designed to manage and optimize a site's energy consumption and to cut the cost. Okay, it is very important in power system operation, and newer technologies are being introduced with the objectives of energy optimization, peak power reduction, improved reliability, and reduction in emission, etc. So demand side management is the demand response, and that is the mechanism in which the end user of electricity are encouraged to take part in reducing the peak load on the system by changing their normal energy consumption. Normally, what we do at home is we used to switch on the motors at 6 o'clock. Like that, we have from 6 to 8 in the morning hours, and from 6 to 8 in the evening hours, the demand will be more, because we try to switch on all our grinder, mixer, motor, everything will be switched on from 6 to 8 in the residential places, isn't it? So the consumption will be more during that time. That will be the peak occurs during those times. Okay, if you are capable of shifting those things, that is, we can use a washing machine during the lean load period time, so that we can conserve the energy. Like that, we can from the consumer side, we can do a lot of things in order to shift the energy consumption from the peak load time period to a low load period. Okay, this process will lead to reduction in the overall system peak load, as the end users will shift the operations of their load from peak hours to off peak hours. Okay, so so that they will be paid some incentives, or the price based amount will also be given to the utilities. Okay, the demand response is a voluntary change in demand. And the change can be a reduction of demand when the electricity price is more, or to move a demand to a period of lower electric prices, and to increase the demand when the load is less. Okay, so why we are trying to increase the demand when the load is less, or else the base plant which is operating will be going without load. Okay, so that will cause a waste. So in order to fill that gap, we are trying to shift our load from the peak load period to a low load period. Okay, so we will ask the power users to use less during the peak hours, and and due to participating in that, they will get paid for it. That is, they will be given some incentives. Okay, and to avoid this also avoids blackouts by using less instead of building. Or else what we have to do, we have to build more power plants in order to supply the demand. That cost can be reduced if we try to shift our load. See, this is a load curve. Okay, this is a load curve. A load curve is a graph which shows the consumption during every hour. So this is for 24 hours for one particular day. The consumption. Okay, load in megawatts versus time. Okay, if we see there are peak. The peak exists in 2 times. Okay, during the evening 6 and the morning 6. Okay, 6 to 8. So if we are capable of shaving this peak, then it will help us in order to reduce the cost of generation. Okay, it will help us to reduce the cost of generation. Normally what we want is, we want to have a load curve which is very flat. Okay, which is very flat, but that is impossible. There are many peaks as well as valleys, and these peaks and valleys can be distributed. So that is what is the demand response. These peaks and valleys can be this peak usage can be shifted to this valley points, which will help to make the load curve flat by shifting our load to a different time of usage. Okay, for that, what is needed in order to do this shifting and all, what is needed? We need smart meters. Okay, we need smart meters which will say us regarding the amount of electricity charged during the what time period, how much electricity is available, and whether we can use it or not. Those things can be given by means of smart meters. And we need a two-way communication. We need a bi-directional communication. Till now the communication was only in single direction, that is from the utility to the transmission, distribution, like that. But now we need a bi-directional communication. So the changes in this electricity usage by the end user customers in response to changes in the price of electricity over time is expected to produce major changes in the normal consumption pattern, and this will help the utilities in undertaking effective management of power distribution. Okay, so that is what called as demand response. So demand response in a smart grid involves changing the electricity usage profile of the customers according to the energy pricing for economic advantage. But it gives loss of comfort as well as energy loss and productivity loss for the user. Okay, so it is an opportunity for the consumers to play a significant role in the operation of electric grid by reducing or shifting the electricity usage during peak periods in response to the time-based rates or other form of financial incentives. So the customers can participate manually, but by contacting the utilities. But it is best for large. This will be best only for large commercial industrial facilities that have a substantial flexible energy load and have staff on site that can react to the request from the utilities. The utilities will say this time you can on and this time you can off. That will be possible manually only when it is a large commercial and industrial area. Okay, for consumers like us, we need some smart meters, isn't it? So demand response, it is a comprehensive energy strategy. What is my strategy? How I am going to buy the power, how to control it, how to optimize it, and how I am performing. This is the energy management life cycle. Okay, so in the strategy, energy and sustainability comes under the strategy, and how to buy the energy procurement services, and how to control the power reliability and metering will help to control, and to optimize the infrastructure and efficiency upgrades will help to optimize, and measurement and reporting will help to say regarding how the performance is. So how to perform in the demand response by the end user. It can be from the end user, it can be by bidding in the marketplaces, and by performing demand reduction as agreed in the supply contract, or by market participants, and by utilizing remote control for reducing load as agreed in a supply contract. So the importance of demand response, it is already, demand response is already existing physical resource, resource for maintaining the balance without major investment. Without major investment, we can use the same resource. Okay, so there is a substantial technical potential for demand response, and the prices, price spikes are a risk for market participants, and the consumers' risk aversion will contribute to the demand response, contribute to more stable market prices. Okay, so the demand response is a prerequisite for an efficient market. If the power sector should be efficient, then the demand response should be a prerequisite. So there are three types of demand response. Okay, there are three types of demand response. One is the emergency demand response. Second one is the economic demand response, and third one is ancillary demand response. Emergency demand response, it is employed in order to avoid involuntary service interruptions due to time of supply scarcity. Okay, during the times of supply scarcity, emergency will be employed, and this economic demand response, it will be employed to allow the electricity consumers to curtail their consumption when the productivity or the convenience of consuming that electricity is worthless. Okay, and then and paying for the electricity. Okay, so economic demand response. Then ancillary service demand response consists of a number of specialty services that are needed to ensure the secure operation of the transmission grid, and which have traditionally been provided by generators. Okay, so these are the three different types of demand response. So demand side management and demand side management, it is a set of programs which will enable the customers to plan and monitor activities related to the use of electricity. Okay, so it helps them to play an important role in shifting their own demand of electricity during peak periods to consume less power, and to shift the demand to off-peak hours to smoothen the demand curve. And by reducing the overall load on an electricity network, then demand side management can mitigate electrical system emergencies, increasing system reliability, and reducing the number of blackouts, regulating the voltage profiles, and balancing the grid. These are the usefulness of demand side management. So the objectives of demand side management. The first one is the power shortage mitigation. That is, normally we come across power shortages. If we are capable of implementing this demand side management properly, then we can avoid this power shortage. Okay, then seasonal peak reduction. Okay, seasonal peak during summer season, normally more ACs will be on, and so there will be peak. So those peaks also can be reduced. Okay, the cost effective energy savings, lowering the cost of electricity, and reduction in emission of greenhouse gases. These are the objectives of demand side management, and we are targeting at percentage reduction in load growth, and savings in kilowatt hour, and savings as a percentage of total resources, and the investment to meet the load. Okay, these are the targets. These are our targets. So to achieve the widespread demand side management success, two things are required. One is the energy efficiency, another is the load leveling. Energy efficiency by means of new technologies, we can use good apparatus, or we can use good equipments which are very energy efficient. And load leveling we can do by means of pricing, that is the real-time pricing, and then off-peak incentives and energy storage. Okay, these are the three things which will help us to level the load. So our motive is to know about this, the energy usage informations, and the efficient communication between utilities and customers, and the consumer enrollment in demand response programs. Okay, and in-house technologies, that is availability and purchase, device provisioning. Okay, so coming to that, we can do this demand side management properly when the grids are smarter. Okay, when the grids are smarter, because I said that we need a two-way communication instead of single direction communication. Okay, so power grid before the 1990, it is generation, transmission, distribution, and then consumers. It is a single direction flow. Okay, they don't the utilities will generate, transmit, and distribute, and the consumers will just consume and pay for it. This is what happened during before 1990s in power grid. Okay, but nowadays we are shifting to bi-directional communication, and the grid is becoming smarter. Okay, the grid is becoming smarter. We are using the same energy generation, transmission, distribution, but the distribution and consumers, it is a bi-directional power flow. The bi-directional communication is there. Okay, bi-directional communication between the distribution end and the consumer end. Okay, for that we are what are the things extra needed is the energy management and demand management. In energy management, the traditional risk settlement, billing, scheduling are all used. Okay, and in demand management, the customer energy management system, and advanced metering and communication, all these things, control, energy control are all used. So there is a bi-directional communication between distribution end and the distribution and the consumers. So after 2000, the grid has become smart. So the smart grid, it is a modernization of electricity delivery system, so that it monitors, protects, and automatically optimizes the operation of its interconnected elements. The smart grid, it is an integration of information and communication system into electrical transmission and distribution network, and it is a flow of electricity from utility to consumers, becomes a two-way conversation and two-way flow of information. Smart grid, the smart grid, the utilities are poised to move from traditional power system to a highly flexible, secured, and green power system by using integrated two-way communication and advanced control technology. So smart grid, it will improve the ability of electricity producers and consumers to communicate with one another and make decisions about how and when to produce and consume electric power. Okay, this emerging technology, it will also allow the customers to shift from an event-based demand response, where the utility requests the shedding of load, towards a more 24/7 based demand response, where the customers see incentives for controlling load all the time. Okay, and it increases the opportunity for demand response by providing real-time data to producers and consumers. So the smart grid, it consists of transmission, distribution, system operation. In transmission, the asset management, the losses. In order to reduce the losses, we go in for HVDC, UHVAC, etc. And in distribution, we go in for advanced metering infrastructure and asset management. And system operations, the self-healing grid, VAMs and adaptive consists of smart generation, which consists of which includes the renewables and microgrids, and smart transmission, which will include the integration of renewable energy systems and synchrophasor technologies, that is the placement of PMUs, PDC analytics, etc. Okay, and smart distribution. In smart distribution, advanced metering infrastructure, outage management system, peak load management, power quality management, electric vehicle charging, etc. are coming under smart distribution. So when we come to existing grid, it is an electromechanical, but smart grid is digital. And in existing grid, one-way communication; in smart grid, two-way communication. In existing grid, centralized generation, and smart grid, this we are including all the renewables like wind, hydro, then solar, biogas, all these things and microgrids are being formed. Okay, and then less in the case of existing grid, but in smart grid, throughout the grid we have sensors, and then monitoring, manual monitoring in case of existing grid, and self monitoring in the case of smart grid, and then manual restoration in case of existing grid, and self healing in the case of smart grid. Okay. Existing grid, there are many failures and blackouts, but since the smart grids are adaptive, it can be islanded, and failures, blackouts are being avoided. And there is a limited control in existing grid, but pervasive control in smart grid. And then few customer choices or the customers are not being given more importance, but here the customer choices are many, and we participate in making the grid smarter. The customers will participate in making the grid smarter because the customers are the main in smart grid. So the futures of the smart grid, it is a proactive management of electrical network during emergency situation, and a better demand supply or demand response management is available. Better power quality, it will reduce carbon emission, increase the demand for energy. That is requires more complex and critical solutions with better energy management. The objectives of smart grid is self-healing, that is the grid is rapidly detecting and analyzes and responds and restores. Okay, it empowers and incorporates the consumer. Consumers are given more privileges. Okay, and is tolerant of attack. The grid mitigates and is resilient to physical cyber attacks, and it provides power quality needed by 21st century users. The grid provides quality power consistent with consumer and industry needs, and it accommodates a wide variety of supply and demand. So why we are moving into the smart grid? Because of the reduction in carbon footprints, and then it improves the distribution management and decision support, and it is capable of self-healing, automatic control for distribution, sensing and measurement technologies, increased efficiency. All these factors contribute and make us to move towards the smart grid. So this is the diagram for smart grid. I hope I am audible. Any? I'm audible, isn't it? I hope I'm audible.
Yes, ma'am, audible.
Okay. So generation, transmission, distribution, energy storage. Then in the distribution network, we are having the microgrids and other renewables like wind farm, rooftop, solar, residential buildings, and then commercial industrial buildings, electric vehicle charging, everything. See the arrow, it is bi-directional. The distribution network, in the case of smart grid, it is bi-directional. Okay, power flow is bi-directional. So what are the things that help us to make this is the neighbor area network, that is advanced metering infrastructure, AMI. It is very much useful in smart grid. Advanced metering infrastructure, then the extended area networks, the field area networks, the home area networks, building area networks, and then industrial area networks. These are the things that help us to make the grid smarter and helps the customers to participate in the power business. Okay, the smart grid and the local energy network. If you see the utility, there is a communication from the utility to the end user via internet, and then the consumers building has energy management system, and then there are dynamic system control. The control is made by means of data management with the help of these computers, and plug-in electric vehicles, distributed energy, distributed generation and storage, and then the smart devices are all present in the consumer, and they are being controlled. Okay, and renewables like PV, wind, etc. are also added to this local area network. So smart grid and local area network. So smart grid, it consists of smart appliances, then the demand management, and then there is a central processing unit, storage, also storage, then the generators, which is being central generations, as well as the distributed generations, are all added to this grid in order to make it smart. So coming to the characteristics, let us see the characteristics of a conventional power grid and smart grid. So architecture, the architecture for a conventional grid is hierarchical and vertical structure. It goes vertical, there is only vertical, but here it is unbundled and it is distributed. It is unbundled, distributed. Then the consumer participation, in the case of conventional power grid, consumers do not participate, non-participative and uninformed. They don't know anything about the power generation or other things. They just will consume. But in the case of smart grid, it is being informed, and the consumers are participating in the power distribution. Okay, and then generation and storage option. In the case of conventional power grid, it is a central generating unit and no storage framework, but here DERs with plug and play features are available. And coming to power quality, conventional grid power quality is very it is, we do not focus on power quality as well as the outages, but in the case of smart grid, power quality is priority, and we focus much on the power quality. And then new product and services, it is in conventional grid, it is limited, poor, and the customer's focus is less. But in the case of smart grid, it is better market and services are there for customers. For asset optimization, it is very poor and little data integration. But in the case of smart grid, data driven, predictive, as well as asset management is there. Predictive asset management. Self-healing, conventional grid, it is not self-healing, but in the case of smart grid, it is self-healing, automatic, predictive, and fault addressed. The other characteristics are cyber attack. It is vulnerable to cyber attack in the case of conventional grid, but this is resilient to cyber attacks. Disaster management, it is slow and reactive. reactive response to the natural disaster, but here it is a quick and proactive response to disasters. In the case of event analysis, it is slow and tedious event analysis process for conventional grid, but here smart analysis with forecast. Then communication, it is one-way communication in the case of conventional grid, integrated two-way communication in the case of smart grid. And predictive, non-predictive process and applications, here it is predictive process and applications. Intelligence, limited intelligence in the case of conventional grid, but smart grid, it is very intelligent and integrate the process critical informations. Okay, and coming to the efficiency, conventional power grid has a poor efficiency, but smart grid, it is efficient. So these are the characteristics. So what are the components of the smart grid? It is the smart meters, then the Phasor measurement units. We call it as PMU. These are the heart and brain of that smart grids. And then the information transfer, distributed generation. These are the parts of components of the smart grid. Coming to the smart meters, these smart meters, they are the electric devices then that can record information such as consumption of electric energy, voltage level, current and power factor. This communication information to the, this communicates the information to the consumers for greater clarity of consumption behavior and electricity suppliers for system monitoring and customer billing. Okay, the smart meters will help to implement time of use pricing, which ties pricing to an on-peak and mid-peak, off-peak schedules. Okay, so smart meters only help us a lot in order to do the two-way communication. Not only that, it helps the consumers to take part in the power business, that is the power distribution business. Okay. Then coming to the Phasor measurement unit, this Phasor measurement unit, it is a device, it is used to estimate the magnitude and phase angle of electric voltage or current in electric grid using a common time source for synchronization. Common time source for synchronization. The if you measure the voltage and current, etc., at different places, there must be a common clock, okay, in order to measure that. So that is being done with the help of Phasor measuring units. Then the information transfer and distributed generation. Initially the power line carrier communication was there, then the copper wire, fiber optics, and now it is wireless communication. So smart grid, it is a communication between the utility and the customers, and energy is a management challenge, but demand response is a management solution. The factors that contribute to the smart grid are the rising consumption, more ambitious environment goal, and then there are three drivers and three accelerators. The drivers are the growing electricity demand and the carbon dioxide emission, and the existing constraints on the existing network, that is limits on generating capacity, limits on network extension, aging of infrastructures, and the integration of intermittent and distributed generation. These are the constraints on the existing network. The three accelerators are new technology available, information. information technologies, cyber security, energy storage, power electronics. These are the new technologies available. With the help of these technologies only, the grids are becoming smarter. Okay, the active government and regulators, and then the active end users. Okay, active end users are nowadays very active. Okay, the coming to the energy management system, we have to plan, do, check, and act. Okay, plan the energy and energy performance indicators. What to do? The energy purchasing as well as design, and checking is to monitor and measure, and act is energy in performance and end review, end people review. Okay, so the advanced metering infrastructure, it will provide an interface between the utility and customers. It is a bidirectional control. It will help in advanced functionalities like real-time pricing, accurate load characterization, and outage detection. This AMI is advanced metering infrastructure, which tries to integrate the system of smart meters, communication network, and data. Phasor measuring units, it will measure the electrical wave and it will determine the health of the system. It will increase the reliability by detecting the faults early and allow the isolation of operative system and the prevention of power outages. So smart meters, this AMI is the heart of that one, and it consists of this advanced storage, smart meters, advanced customer side, advanced storage, smart appliances, battery vehicles, and demand response resources. And in the case of energy providers or services, energy service providers, it is billing, distribution, meter data management, and outage management. Okay, so this AMI, it is a basic element of the smart grid. Its role is to furnish informations and active interactive capability to service providers and customers. Okay, this AMI, it consists of smart meters. It integrates two-way communication infrastructure, active customer interface, and meter data management systems to gather and to store customer data. Okay, in addition, this AMI also provides interface to other electricity company enterprise systems. So smart meters, it is the central nervous system of the AMI, and it the ability to collect consumption data in discrete time interval allows the utility to charge the time differentiated rates for electricity usage. The meter can also perform other useful advanced functions such as remote connect and disconnect. It is also a key need for implementation of demand response. Demand response can be implemented with the help of the smart meters only, because we must be knowing at what time the load is less and at what time the load is more, and during that time our equipment is to be on and off. For example, we can shift the washing machine to a period where the load is very low, so that we can get incentives and try to flatten the load curve also. Okay, so for those things we are in need of this smart meters. So the smart meters, it recognizes and it will record the electric consumptions. It will relay information. It gives information to the central monitoring station. It will replace the traditional meters and the power outage notification and power quality monitoring and time of charges. Depending upon that, it will help us to on the equipments. Okay, here. This is used to enhance the power system measurement and enable the transformation of data into information. It will evaluate the health of the equipment and integrity of the grid and support advanced protective relaying, and it will enable the customer choice and demand response and help relieve congestion. Okay. initially we used to in order to keep the load balanced with the supply, normally we used to load shed. Okay, but nowadays it is not there. It has being reduced. It is being reduced. But during those times we used to have the load shedding. During that load shedding, what will happen is for a part of the places there won't be supply. Okay, so the people will be suffering a lot. They were helpless. They were helpless. So what happened is they started investing in the diesel generators for their own houses, and some people also started investing in the renewables like solar power, etc. And they some of them started purchasing inverters. Okay, but these are all the expensive for middle class family, and it is out of reach for the poor. Okay, so they cater to the part of the lighting load only. Even though if we purchase these things, it helps just to have a fan or have a fan and light, etc. Okay, it is difficult to use refrigerators, motors for water pumping, and ACs and all. So the inverters many people, they started purchasing inverters, but these inverters are energy guzzlers because they consume nearly twice the energy to change their batteries, to charge their batteries after they have been used. Okay. Okay, further they increase the loss due to harmonics. The harmonics are also very high. If you see the grid, during the past, the communication was by means of this normal dialing phones. Okay, then it became the communication became for transmission control centers and distribution control centers. But in future the communication will be between all the suppliers, transmission, distribution, as well as energy consumers, which will make the grid very smarter. So the distributed generations, we can use renewable energy resources, photovoltaics, solar thermal, which is being used for heating, waters, and process in process industries, and wind, small wind systems up to 50 kilowatts, and then large wind systems, biomass, etc. will come under the distributed generation using renewable energies, and storage technologies. The storage technology, we can have mechanical, electrical, or chemical, electrochemical storages. Okay, so mechanical storage, what are the mechanical storage? It is pumped storage by means of hydro plant. Okay, pump during off-peak period, we can pump the water again. Okay, during the peak periods, electricity will be produced. During off-peak periods, the water will be again pumped by means of pumped storage plant. Here in Kadambare, we have a pumped storage plant. Okay, so then compressed air energy storage, then flywheels. These are all the mechanical storage equipments. And then electrical storage equipments, supercapacitors, then superconductor, conducting magnetic energy storage, that is SMES, superconducting magnetic energy storage. Then the chemical storage, it is the fuel cells or chemical storage. Then electrochemical storage, batteries, electrochemical storage, all sorts of batteries, the lead acid battery, sodium based batteries, lithium ion batteries, zinc based batteries. So different batteries will come under the electrochemical storage. So there are a few challenges. They are the voltage stabilization, power management, power PQ management, protection, grid integration, stability issues, islanded operation. These are the few challenges which can be addressed. So the people, those who are doing research, can think about these challenges in smart grids and can address those things, address those factors. Okay, and R&D needs are there in this design of a microgrid architecture, AC/DC microgrid, converter topologies, control architectures, MPPT scheme, and adaptive and fast protection schemes, island detection and management schemes, smart inverters, converter with network control features, and virtual inertia generations, micro EMS, energy management systems. So these are the places where R&D can be done. So those those are doing research can be focusing on these areas and can try to address the problems in these areas. So with this, I thank you for giving me this nice opportunity, and any questions?
Thank you, madam. Thank you.
I hope you might have understood about the demand response and the customers' involvement in the demand response in order to decrease the price, energy price.
Participants, you may ask questions. If you have any queries, you may ask.
How should I change the host privilege? I'm not getting anything.
No need to change, madam. We can wind up.
Okay. Okay then.
One question from participant.
What question, sir?
How to apply for microgrid?
Microgrid is nothing but a small a part of smart grid, and the advantage of having this microgrid is when there is any disturbance, then the microgrid will be islanded. That is, it will operate as a its separate entity without making any disturbance with the whole network, and it will reduce the blackouts, brownouts of the grid. So there are two types of microgrids: AC microgrid and DC microgrid, in which renewable energies will contribute to those microgrids. Okay, so you can. There are certain challenges in that integration of these microgrids. So you can try to do certain research in that.
Okay, madam. Thank you. Thank you very much. Any other questions? Okay, madam. We can wind up now.
Okay, sir. I will end the meeting.